Stevenson High School. Erdmann is walking through the hallway. He's an invader that has just moved here from Kenosha, Wisconsin.
I'm NHS Secretary, NHS Vice President, NHS President. Kind of a big deal. An NHS All-Star. And I like Michael's cheese sauce.
Hey you, I'm the hall monitor. Where's your hall pass? Hey, popular couple.
I'm
whoever
Bobby
wants to
B.
be like. I found these Augustana diplomas from an invader, and I thought you guys should know.
Thanks, man. See you later, babe. I'll remember these.
We don't like your kind here. Wait, did anyone understand what just happened? Let's go through that again, step by step, explaining each process.
I was gonna say.
Yeah.
Welcome to Stevenson High School. Erdmann is walking through the hallway. He is an invader that has just moved here from Kenosha, Wisconsin. Alex, a macrophage, arrives and takes in the antigens via phagocytosis. Each of the antigen are transported to the cell surface with the help of class II MHC proteins. The macrophage ingests some of the infectious agents and also displays the antigens on the surface. He has now become the antigen-presenting agent. Meanwhile, Jeremy, the hall monitor and helper T cell, arrives. The hall monitor is now taking the antigen and binding them to its surface due to the T cell receptors. Since he has these T cell receptors on his surface that correspond to the specific antigen, he too can display the antigen. The antigen fragments on the antigen-presenting cell are held in place by class II MHC molecules and the protein CD4 on the helper T, which binds the class II MHC molecules to the T cell and antigen-presenting cells join. The helper T cells then proliferate, dividing many times due to the secretion of IL-2, which is interleukin-2, a cytokine that triggers cell division. This then activates the B cell, represented by Sujin and Bobby. The B cells proliferate and clone identical cells. This concludes the activation phase of humoral immune response. The next phase is called the effector phase. Cytokines cause the B cells to proliferate and differentiate into plasma cells and memory B cells. The plasma cells secrete antibodies that are specific to the antigen. The antibodies then bind to the antigen, and the memory B cells have membrane antibodies that remain in the blood. Then the neutrophils, which are macrophages, arrive and eat
the invaders with antibodies on the surface.
And then the cell dies.
Okay, can everybody scooch together like in a group of 5 for the Q&A? Well, the only question I had at the end, I just wanted to make sure everybody understands. I think you guys understood. Bobby changed roles there right at the end really quick. He went from being a plasma cell.
Yeah, no, I was a memory cell. When I said I'll remember these, when he gave me the diplomas, that's because I'll remember the antigen. And then when I took off the glasses, I became back to Erdmann or the pathogen.
Got it. Okay.
And then when Sujin threw these at me,
Which are the antibodies?
right, I caught them, and then that allowed the neutrophil to figure me out.
And there's a nice connection to when we were talking about neutrophils with the inflammatory pathway. The neutrophils are just general gobblers. They see something hooked up with antibodies and they just gobble it, but they don't become antigen-presenting cells to set off the specific response. They're there just to kind of clean up what's already been started. Okay, what other questions we have for this group? This is probably the most complex pathway that you'll have to know, so there should be a lot of good questions, even though they did a good job. Well, I guess here's the question to the audience. Did they generally follow the sequence of events pretty well?
Yeah.
Yeah, go ahead, Ben.
So in the first step, it says macrophage ingests a pathogen or a B cell membrane receptor binds to an antigen. This is like for you or for you. Like why is it either or?
Well, yeah, because
Starting.
so when they make the memory B cells, they keep the specific antibodies on the surface for if ever the pathogen comes into the body again. So this could either start with a new antigen or the memory one. So which makes it a quicker response. So you can.
So the B cell would be like a second or third time it came.
Yeah, if it comes in again, then the B cell's already there, recognizes it, so it can start earlier and beat it quicker.
So what's the key to the memory? What don't you have to go through if you have a memory cell sitting there?
You don't have to go through the whole phagocytosis from the macrophages and then presenting it to the helper T and then to the B cell.
So just the memory will hook up directly with the antigen of the pathogen or maybe the antigen of an antigen presenting cell, and immediately you'll get clonal expansion, right? Can anybody describe what clonal expansion is? That's usually what kids don't get. I'm going to show you a video here in just a second as soon as we're done with the Q&A here. But that memory cell, it's a single cell. So if it ever encounters the pathogen upon the second exposure, that will initiate clonal expansion, which means that one cell will literally become millions of clones of that cell, which means you'll have millions of that cell producing all the same antibody for that one pathogen. So that's the idea. You have memory cells, you just have that one memory cell like laying in wait, and as soon as it's activated, it divides rapidly, becomes millions, and then they're all pumping out antibodies. But that's really hard to visualize. That's why I want to show you the video right now. Any other questions before we take a look at clonal selection and expansion? Yeah?
Okay, so basically when the B cell proliferates all the way up to when you guys like dispose of the antigen and it dies, then or when the cell dies, that's the effector phase. So what's the phase before that?
It's the activation phase. So it's like everything before that when you're activating the memory cells and everything.
So it's just 2 phases.
Right.
Any other questions? All right, nicely done.